To graph things, you use the y equals button. And then it says, look at the top of the screen to make sure the plots are all off. If you go into the y equals button and you see something that looks like this, do you see how plot 1 is like highlighted in black? If you see that, that means this calculator was used for something like scatter plots or something crazy, and there's data in the calculator that is going to completely screw up your graph. So if you see that highlighted, you just arrow up and then hit enter, and that will turn the plot off. You want your y equals screen to look like this. We're going to enter our first function in y1 equals. Remember, your x button is this button right here that I just highlighted in red. And if you're ever looking at your graph and your graph looks funny, say your origin isn't right at the middle, your grid lines look funny, if you push zoom, which is the button right in the middle below your screen, if you push zoom and then standard, number 6, that will give you a standard -10 to 10, -10 to 10 window that you're used to seeing. So if your graph ever looks wonky, try zoom 6 and it should make your graph look better. Okay, so what are we actually doing today? We are going to graph y equals x squared. So number 1, step 1, enter the parent function f of x equals, remember that's just a fancy way of saying y equals, x squared into y1. So x, do you know the squared button? I just highlighted it in red. The button diagonal from the 7 is the square button, and that allows you to square your x. Okay? And let's push graph and see what it looks like. And then, to the best of our ability, we can sketch that on our page. Okay, a couple things to notice. This graph has a vertex that's got a place where the graph changes direction at 0, 0. The picture that we sketched may not be symmetrical, but this graph is a symmetrical U-shape. Does anyone remember what this kind of graph is called? It's called a parabola. I know it kind of looks like parabola, but it's not some evil disease that's going to kill us all and start the zombie apocalypse. It is parabola, not parabola. Got that? Parabola. If you go into another math class and start talking about parabolas, the teachers are going to be like, wait, who was your math teacher last year? And then they're going to come give me a really hard time. So it's a parabola. Parabola. I want you to sound like intelligent math students. Parabola. All right. Notice this graph opens up. The ends of the U are pointing upward. Step 2, we are going to graph x minus 3 in parentheses raised to the second, but we're going to leave this parent function in y1. So go into your y equals. And in y2 equals, I want you to enter parentheses, x minus 3, close your parentheses, squared. Anyone want to take a guess what you think this graph is going to look like? Nobody's brave. Nobody wants to guess. It's going to look like this as I point to my computer screen, my calculator screen. So notice the general shape of the parabola is the same, but this time the parabola has moved 3 units to the right. So our vertex is at the point 3, 0. It moved right 3. And really what I'm trying to accomplish with this problem is have you make the connection between right 3 and the minus 3 inside the parentheses. So How do you suppose this would be different if it had been plus 3 instead of minus 3? So if it had been plus 3, what would have been different? It would have moved left 3. Do you notice it's backwards? Plus moves to the left, minus moves to the right. Do you remember doing this with absolute value functions? And anything inside the bars with the x, it was backwards and it moved the graph side to side, the reverse of what you would expect. So anything inside those parentheses is going to move the graph side to side. Minus will move it to the right, plus will move it to the left. All right, in your y2, so go back into your y equals button, and this time delete out y2 and enter 2x squared. So for step 3, enter h of x in there, sketch that graph, describe how it's different, and then clear out y2 and enter x squared plus 1, sketch that graph, see how it's different. So explore those graphs for a minute. Okay, I will try to use both letters and examples for this. Translation means this graph is going to move or slide either horizontally, left or right, or vertically, up or down. So if you have a function that has something added or subtracted inside the parentheses, that h is going to be the side-to-side movement. And this is backwards. So plus h moves left, and minus h moves right. For vertical translations, it's not inside the parentheses. This time it comes after the x squared. Plus k moves the graph up, minus k would move the graph down. Notice that those movements are completely normal. Plus means up, just like you would expect. Minus means down, just like you would expect. All right, reflections. We're going to start with a vertical reflection. And to do this, on our graph, I'm going to punch in negative x squared. I want you to see what happens. What happened? It flipped over the x-axis. So a reflection, if we have y equals negative x squared, it will flip it over the x-axis. You may see the phrase reflection in or over the x-axis. And it might seem weird that a vertical reflection is over the x-axis, but think about it. If something reflects from above to below, up, down, it's reflecting over the x-axis. You may see the phrase in the x-axis means the same as over the x-axis. I don't really understand why they use that phrasing, but they do. Horizontal reflections are kind of weird. It would look like this. Y equals parentheses negative x squared. And I want you to see why this is kind of silly. What just happened on my graph? The blue graph graphed, and then the red graph graphed right on top of it. What's really happening is the right side of the blue graph becomes the left side of the red graph, and the left side of the red graph becomes the blue side of the red graph. Did I say those colors correctly? I don't know if I did or not. But because we're reflecting over the y-axis and this thing is symmetrical, it's reflecting onto itself. So horizontal reflections with parabolas are honestly kind of dumb because they don't really do anything. The phrase here would be reflection in or over the y-axis. And I'll tell you right now, I am not going to use this one very much because it's just kind of pointless. So get this in your notes. If you're watching the video, pause so that you can write it in there, but get this in your notes and then we'll talk about it. So vertical stretches and shrinks, there's a number multiplied in front of everything. If there were parentheses, that a value would be in front of the parentheses. So if there were parentheses in here, the parentheses would still be just around the x. A horizontal stretch or shrink is actually the reciprocal of the factor. So if you wanted to horizontally stretch by a factor of 2, you would put a 1/2 in here. So an example is y equals 1/2 x squared. That would actually be a horizontal stretch by a factor of 2. The reciprocal of the stretch or shrink factor goes inside the parentheses. It's weird, it's messed up, it's crazy. Basically, do you notice that inside the parentheses, anything that's horizontal is kind of backwards, messed up, crazy? Anything outside of the parentheses, anything vertical is like totally normal and fine. At the bottom of the page, there's some examples, and we need to describe the transformations. Some teachers would say, describe the transformation using full sentences and correct vocabulary. I really don't care about that. I want to know if I gave you a lineup of 5 graphs and gave you 5 equations, could you match the equation to the graph based on the transformation? So that's what I really want you to be able to do. So this first one, what does this plus 4 indicate? Left 4. What does the minus 1 indicate? Down 1. That's what I want you to be able to do from these equations. So B, what does the minus 3 mean? Right 3. There's a couple things happening in C. First is the negative. The negative is not inside parentheses, so it is a vertical reflection. So this is a reflection or a flip over the x-axis. The 1/2 is not inside parentheses, so it's a vertical stretch or shrink. That means it is a shrink, a vertical shrink. It will make the graph look wider. The parabola will be wider because of the 1/2. Okay, D and E we will talk about, but I will never put D and E on a test because I am not evil. However, F is a very, very likely test question, so you may want to make sure you get F down perfectly. So let's talk about F, and then I'll put the stuff for D and E up there. First of all, the negative. Notice the negative is outside of the parentheses. That would flip the graph over the x-axis. In layman's terms, it would make the graph open down instead of opening up. So instead of being a U shape, it would be a hill shape. What does the plus 3 do? Left 3. And what does the plus 2 do? Up 2. Okay, turn to the next page. We're going to write some transformations, and then we'll be done with notes for today.